In a previous video, we covered ways, and we said that ways were like lines. They consist of nodes in a list, and the order in which the nodes appear in the list determines the shape of the way, as well as the direction of movement in the way. In the last video, we talked about closed ways, and we mentioned that nodes have ID numbers, which are unique identifiers that help the server keep track of them. So this time we're going to talk about routing or navigation. Routing is the term used for having the computer give us directions from one area of the map to the other. So let's draw a map. And in this map we'll have several streets. So I'm going to change colors. And we're going to call this first one Main Street. And Main Street is going to be a primary way. So let's sort of tag this here. I'm just going to make this is not a part of the way. It's just an indicator. So we'll name equals Main Street and highway equals primary. And we talked about this a little bit in a previous video. The tag for very large streets is primary, and we'll go through a few other street classifications. So let's do Oak Street, and we'll do that one now. And just make another identifier, name equals Oak. And Oak Street isn't going to be quite as large as Main Street, so we'll say it's a secondary road. We'll indicate that with highway equals secondary. And we'll make two residential streets. Make one that goes off this main road. And we'll call that one, oh, I don't know, Elm Street. Oops. And highway equals residential. And last one, let's see, running out of colors here. So let's just do this one in black. And we'll call this one, let's just draw it first. 3, 4. We don't have to have 4 nodes, but I like consistency. So make the highway equals residential. And name, we'll call that Cedar Lane. Now I said in the previous video that the ordering of the ways determine the traffic flow. That's true, but in the case of tags with highway, it's always assumed to be bidirectional unless we specifically say that these are unidirectional. So let's actually do that. Let's say that Cedar Lane is a one-way street. So the tag for that would be one way equals yes. And one way. And so let's draw little indicators on our example to indicate that this is a one-way street. And let's also say that Oak Street is also one way. So let's do it like that. Okay, so let's say we wanted to get from Elm Street onto Cedar Lane. How would we do that? Well, even though this map is a little bit cluttered, we can see that we would just drive down Elm Street, turn onto Main Street, Oak, and then eventually onto Cedar. But the computer doesn't know that, and the reason the computer doesn't know that is that in OpenStreetMap, for ways to be routable, they have to share a node. So let me move a little bit and draw that. Oops. mark for now. So let's draw two ways. And I'll just have three nodes. And we'll make another one, different color. The names and all that don't matter. So right now we have these two ways, and they geometrically intersect, right? They intersect at this point, but from the OpenStreetMap point of view, they are not connected. And the way we say that ways are connected in OpenStreetMap is if they share a node. So what I mean by that is, and as we talked about in a previous video, uh, a way is just a list of nodes. And so let's just come up with an example here. Let's say that this is node 300, 301, 302, and that this other way has nodes 100, 101, 102. And you can see that the list for this way, which we'll just call way A, is different from the list for way B. And we'll draw those out here on the side. So way B has 300, 301, 302, and way A has 100, 101, and 102. They don't share these nodes. We talked about how nodes have unique identifiers. The thing to know here is that the identifiers aren't in any way, the node identifiers aren't tied to the ways in any way. So to connect these two ways, what we need to do is we need to make a new node that's shared between them. So let's do that. And we're going to make a new node. Now you just have to know that this node is in both ways, and we'll actually draw that. So let's call this, the numbers aren't important, and that's going to be important to know later that the ID numbers have nothing to do with reality. So we can call this 700. And now our way A has nodes 100, 700, 101, 102, and this way B contains 300, 301, 700, and 302. So it's because that these two ways share this node 700 that the computer knows that it can route traffic between them, that there's an intersection and that the cars can turn on this way. So we can go back up here to our previous example. Oops. And we see that none of these ways are connected. So what we need to do is to draw new nodes and add them to the ways. And the editor will usually help you if it sees that the two ways are intersecting and that you're putting a node at the intersection. Usually the editor will interpret that correctly and add it to both nodes. It'll also worry about the ordering, so you don't have to worry about all that. You just have to put the node in the right place. The last thing I do want to mention, though, and let's move back down here to a new area, oops, is you will sometimes see nodes or ways that look like this. And so you can see here we actually have two nodes. They're close together, but they don't actually meet at the intersect point. And what we can usually do with most editors is select both nodes and then use, sometimes they call it a merge or sometimes they call it a join. But what it'll actually do is turn those two nodes into one node. So what you'll get is just one node right in the center, and these two nodes will go away. So they'll go away and you'll be left with one in the center, and that node will be connected with both ways. So that's how you solve the problem of two roads not intersecting and not being able to route across them. Okay, well, now we've talked about routing. We'll go into a little bit more depth on different ways to do routing in the next video. So see you then.